Section 8.1, graphical solutions to trig equations. Now, what we're going to do for this is we're going to solve trig equations using our graphing calculator, and we're going to be able to find all of the solutions. So in order to solve trig equations graphically, the first thing you're going to want to do is set the equation equal to 0. After you set the equation equal to 0, then you're going to determine the period of the function f. When you are graphing these on your calculator, you're going to want to graph the function over an interval of the length of p, which is the period of the graph. So you're going to want to change the window. And then use the calculator zero finder to determine the x-intercepts of the graph in this interval. So remember, in order to do that, you hit second trace. And then, of course, that's number 2 is the zeros. And then for each x-intercept, which we're calling u in this case, all of the numbers are going to be equal to x equals u plus np, where of course n is any integer are the solutions of the equation, and p is the period of the function. So the first thing we're going to do is we're going to graph this first equation. The graph's already there for you, but the thing is what you want to do is make sure you're practicing this in your calculator, so you're going to want to follow along. Now, let's go ahead and do example 1 with the intersection method, which I don't usually use this method. I really prefer to use the zero method, but just to show you, you could do the intersection method if you wanted to. If I'm going to do the intersection method for this, I would plug tangent x into y1, and in y2 I plug in -1. Now remember that your mode you want to be in radian, so if you're in degree, make sure you change that over. And then I normally like to hit zoom 7 for a nice window. So this would be my equation, and of course we want to find my intersection. Well, remember for this graph, if you look at it, each of these values that we have, it hits here, 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 and here in my graph. So remember, all of those values are going to continue to repeat for whatever the length of your period is. So you have to figure out, well, what's the period of this function? So the period for this function is equal to, of course, if you look at the tangent of x equals -1, so we know the period is equal to pi because we know our parent graphs. So the period equals pi. So really, I only want to look at the window from 0 to the length of your period. So in this case, I'm going to look at my window from 0 to pi. So I'm going to change my window here from x minimum of 0, and then I'm going to look at from 0 to pi. And remember your key points, then you divide that period by 4. So I'm going to do my key points by pi over 4, and then hit graph. So really, I can see that I only have one solution from 0 to pi that I need for my answer. So in order to find it, I can do second trace, and then of course the intersection on my calculator. Oops. And then I trace over close to that point, and I hit enter 3 times. And it guesses that the intersection is 2.3561. Now, for this equation, I can actually find the exact value of this because you should know from your unit circle what the tangent of -1 is equal to. So if I think about my unit circle, I know that -1, so usually we graph tangent from -pi/2 to pi/2, and in this case we were actually looking from 0 to pi, so -1 would be in this quadrant over here. So in this quadrant over here, I know that tangent of -1 would actually be 3pi/4. So anytime you have numbers where you can find the exact value answer, you're going to want to do that. So all of my solutions would be equal to an x value of 3pi/4 plus the period of the function, so pi times n, where of course n is equal to an integer. This is what we were talking about up here when we said the 0, which is 3pi/4, plus n, which is right there in my equation. The length of the period is pi, so this would give me all of my solutions where the tan of x is equal to -1, because remember that even though we're only looking at the window from 0 to pi, which was from here to here, so this was my one solution, remember every single pi, which is the distance from here to here, we're going to have another place where it hits -1 for my tangent graph. So that's the intersection method, and we've talked about that and we've done that method before. So Remember, you can even check when you have your exact value answers that you have defined. If I were to, on my calculator, do second trace and the value, and if I plugged in 3 pi divided by 4, notice that it gives me the same decimal value that I had before. So whenever you can get the exact value answers, make sure you do that if it's something on your unit circle. Now for the next example, we're going to do the intercept method, which is again the method that I like to do. So the first thing you'd want to do is set this equal to 0, which we could have actually done for the last equation. So let's do that. I prefer usually do the 0 method. So if I did the tangent of x and then added 1 to the other side and set this equal to 0, just to show you that you would get the same solutions no matter which way you did. And if I delete this and hit graph, notice that now instead of looking at the intersection, we'd be looking at the 0, and the 0, if I were to do second trace and find it with the 0 finder, I would see, or if I use the value just to show you 3 pi divided by 4. And it's right there. So I could have used the second trace 0 and did the left bound, right bound, and hit enter and seen the same thing. So for example 2, we're using the intercept method, which is that one I just showed you. So the first thing you want to do for all of your equations, I would do this, is set equal to 0. Now that it's set equal to 0, I have to figure out the length of the window that I'm looking at. So for sine of x, and since I don't have a b value right here, I know that my sine of x, or my parent graph, the period, is equal to 2 pi. So my key points, remember you take your period and divide into 4 equal parts, so my key points are going by pi over 2. So here's the graph which I did on here, or if you wanted to, of course, we could put this into our graphing calculator. So if I put this in my graphing calculator, I have the sine of x minus 0.33, and then I would hit graph. And of course, I'm not looking at the good window, so I need to change my window from 0 to 2 pi, and I'm going to change my key points to pi over 2, and then hit graph. So that's the window I want to look at, because those are going to help me with my solutions. After that, those are when the values that you're going to just keep repeating for whatever the length of your period is. So notice I have a 0 here, I have one right here, and it stops for one length of one period. So if I do second trace and I do my 0 method, 0 method number 2, I'm going to do my left bound, enter, right bound, enter, and then enter. And so one of my zeros, and again, since we're solving this equation, we're only solving for x, so you only need your x value, would be x equals 2.8053, and then I'd have to do second trace and do the 0 finder again for the other 0 that was over here. So left bound, enter, right bound, enter, and remember those two arrows here should be pointing towards each other, and then enter for guess, and I get x equals 0.3363. So over here, then I know my solutions are going to be, so this one right here was an x value equal to 0.3363, and the other solution here was an x value equal to 2.8053. But remember, our graph continues, so my graph is going to keep going. So because my graph keeps going, I know that this point hits again right here. So what is the length from here to here? I know that's the length of my period, which in this case would be 2 pi. So for each of these answers, you have your 0 plus the distance between each of your zeros, which in this case is 2 pi, n times n, where n is an integer. So then the next one would also be plus 2 pi, n, where n equals an integer. And so these are my two solutions. So then let's go to the next one. So for the next equation that we have, I want to plug this in my calculator, make sure it's equal to 0, which it already is. So these are a little bit harder to plug into your calculator because of that cosine squared. So in my calculator, just to show you how I would do this, I'm going to clear this out. I would have the 4 times the cosine, and then I'm going to put x in parentheses because it automatically in your calculator puts up parentheses there, so you can't do the square. So you can do the square afterwards like that, plus the sine of x, and then minus 2. So now if I hit first I want to figure out the period of my graph. So if I look back over here, remember, how do you find the period of your graph? If I have y equals the sine of bx, remember you take that b value and divide it by the period of the function. So the period would be equal to 2 pi divided by your b value. So in this case, my b value with the x is just 1. So 2 pi divided by 1 is 2 pi. So I know the period of this graph is equal to 2 pi. So that's what I'm going to add to each of my zeros when I'm writing them out. So since that's my period of my function, the window that I want to look at on my graphing calculator, of course, is going to be from 0 to 2 pi, which I already have, and then my key points, of course, would be pi over 2. So if I hit graph, I can see my zeros, and I have 1, 2, 3, 4 of them. So you're going to have to find each of them by doing second, trace, and do your 0, and then do the left bound and the right bound for each of them. And then, so that's one of my answers. So, of course, we would have to do this for this point here, 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 and here. So if you do that in your calculator, just to save us some time, I'm just going to write it out. You should get x equals 1.0030, and x is equal to 2.1386. Here, x would be equal to 3.7765, and here x is equal to 5.6483, plus the period of my function, so 2 pi n, because remember these are repeating because our graph keeps going on, where n is equal to an integer. So these would be all of my solutions. Now, what I want you guys to do is to go ahead and do example 4 and example 5 on your own. So just to help you out for the example number 4. So remember, first you want to set it equal to 0. So I took this to the other side by adding it. Now that I have that, this one's a little bit different. So if I have a tangent and a cosine, well, the tangent parent graph period is pi, whereas cosine is 2 pi. But notice your b value right here is equal to 2. So if my b value is 2, the period would be 2 pi divided by 2, which is pi. Since the period for tangent's pi and this one's pi, I know the period for the entire equation is going to be pi. Let's say that you had 2 different values. You always take the one that's larger to look at the window on your graphing calculator. So you guys find the zeros for example 4 and example 5 on your own, and then we'll check our answers in class.